Hello, this is John from caveofprogramming.com. In this tutorial we're going to start looking at the new operator in C++, and I'm going to split this into several tutorials because there's going to be quite a lot to cover here. So I've got a class that I created in a previous tutorial, but I've also given it a destructor. So our animal class, it has a name instance variable which is private. It's got a constructor and a copy constructor, a destructor. It's got a set name method and a speak method that just outputs the name. And for the constructors and destructors, I've just put some text in there in a cout so that we can actually see that they're running. Let's get rid of this for a moment. I'm going to show you that probably in the next tutorial. So this is how we've been creating an object from a class so far. We declare a variable of the type class and we can call methods on it like this. So if I run this now, we get animal created, that's the constructor running. Up here, we say animal.setName, animal.speak, so it's cat.speak, so I called it cat, but it's a type animal. And then we get my name is Freddy, that's coming from here. Then it says destructor called, because when we have a local variable like this, it goes out of scope, so it's no longer relevant, no longer usable when we hit the closing curly bracket. And when that happens with a variable of a object, with a variable of a class type, so an object, the memory associated with the object is deallocated. That's true for any kind of variable type actually. And with objects, the destructor will be called like this. So when we hit that closing bracket, the variable goes out of scope just before the object is destroyed and the memory associated with it is deallocated. The destructor runs, and we've seen this before. Now there's another way of instantiating an object from a class, and that is to use the new operator. So I'm going to change this to a pointer. Let's say animal pointer pcat1, and I'm going to say equals new animal like this, round brackets. And I'm going to change these variables as well, although this isn't going to work yet. So the new operator allocates memory explicitly. So this is memory that you actually manage yourself. In this case, it's allocating memory for a single object here, although as we'll see in future tutorials, new is very flexible. If I had arguments to the constructor, I could put them in these round brackets here. But if we are calling a constructor that takes no parameters, those round brackets are actually optional, so we can put them in or not put them in, but I will put them in just because this is probably the more common syntax. Now we can't call setName on a pointer, we can only call it on an object, so we can't do this dot thing. Even if we put dereference syntax in here, then this isn't going to work. So if I save this and go to project, build project, this is still not going to work because the dot operator has higher precedence than the star operator. So C++ is going to do all this stuff and then try to dereference the return value of setName, which makes no sense here. We could get this to work by putting round brackets around the dereference bit like this. So if we dereference the pointer first to get the object, then we can use the normal dot syntax with the object. If we build this, it works. But because this is such a horribly unwieldy syntax with these brackets and the stars, there's a special syntax just for working with pointers to objects in C++. Let's get rid of these, and that looks like this. Instead of a dot, we use an arrow. That's a hyphen and a right angle bracket, and we've seen that before with the this pointer. So now this will compile, but it's missing something very important. Let's just run this. We shouldn't really run this because it's not a good program. We'll see why in a minute. So it says animal created, my name is Freddy, but there's no destructor called. And when you allocate memory with new, you must always remember to destroy that object. When you allocate memory with new, you must always remember to deallocate the memory explicitly, because C++ won't do it for you. And in fact, that bit of memory that I've just taken up with new is now probably hanging around in my operating system, taking up RAM completely unnecessarily. So what we have to do is we have to call delete and then the pointer variable like that. And when you call delete, that will deallocate the memory that this pointer points at. So if we run this now, this works. We get destructor called. So always call delete if you call new. A common source of bugs in C++ programs is that delete is not called for every call of new, and that causes memory leaks in your program. Another source of bugs is that you might call delete on a pointer that hasn't been set to point at anything with new, in which case your program is liable to crash randomly. Also, it's quite common to actually set pointers, let's say like this, pointer pcat2, to set them equal to null. So null in uppercase letters, as far as I know, this is basically a synonym for zero. We could use zero. I think it is anyway. Yeah, but anyway, this is a common thing to do. Yeah, we see it's just the same as zero. It actually tells us down here. And that is a way of saying, look, this pointer is not pointing at anything. And then you can check to see if your pointer's null in your program and respond accordingly. So this is just a way of keeping note for yourself in your program of the fact that this pointer's not pointing anywhere at the moment. But if you try to call delete on a null pointer, again, you're pretty certain to get a horrific crash when your program runs. And that's another big source of bugs in your C++ program. So you have to be very careful not to do that. So there are special tools and also special programming techniques to try to help deal with these situations. But for the moment, you just need to make sure that wherever you call new, you must call delete. One last thing I want to mention in this tutorial is just that I mentioned in a previous tutorial that if you subtract two pointers, one from the other, you should store the result in a long. And that's because on this platform at least, and on most platforms, the size of a pointer is actually the same as a long. It's going to be 8 bytes in this case. That's not necessarily going to be the same on all platforms, but in this case, a pointer has the same size as a long. It's worth checking that on your platform just to see what if you do get 8. So if you subtract one from the other, you need to store it in a long variable. But anyway, I'm gonna leave it there for this tutorial, and we've got quite a lot more to look at with this, but I've decided to split it up into several tutorials. So for this tutorial, just to practice this, I'd recommend create a class that has a constructor and a destructor that outputs some text, and just practice using new and delete to create objects instead of using the syntax that we've seen before. Just practice using new and delete and this arrow syntax to refer to the methods. So that's it for this tutorial, and until next time, happy coding.